All right, hello out there. This is Angles in Standard Position, Part 1. Now what I'm going to do here is I'm going to show you how we can draw some angles in a different kind of approach. So I'm going to pull up a grid. So it's on this grid is where we're going to be drawing our angles. And what we're going to do is think of the arms on a clock. The first one, we just put it right here in the positive X direction. So this is like the first hand, as it were. And what we're going to do then is rotate the second one. And this is going to be our center of rotation here. And we're going to build an angle. So for example, if I wanted to draw an angle of 60 degrees, then I would rotate up through 60 degrees, making sure that this was 60 degrees here. So there is a picture on the grid, or standard position, of a 60-degree angle. Similarly, maybe I wanted to draw a picture of, say, 100 degrees. Well, now what I'm going to do is, let's see if I can just clear this stuff off and use the same grid. Okay, so there's my grid, and now I'm going to draw 100 degrees. So I start here. This is always where we start. In fact, this is called the initial arm. Okay, just like the arms or the hands on a clock. So that's the initial one, or the starting one. And then if we want to draw 100 degrees, then we rotate up until we get to 100 degrees, which is going to be somewhere over here. Okay, because we know that when we get to here, that's 90 degrees, so we're going to go that little bit further. So that's my picture of 100 degrees. Now, the nice thing about this system is I can keep drawing as big an angle as I would like. For example, let's say I wanted to go ahead and draw something like 400 degrees. Okay, so I'd go, well, I would rotate up this way. So I just hit 90, then I keep going, I just hit 180, and I just keep going, I just hit 270, now I hit 360. So I got to go a little bit further. So I go, oh yeah, I know I got to go 40 degrees more, and I just drew a picture of 400 degrees. Okay? Because what I did was, if you just follow the spiral, I just rotated my way around this whole thing. Okay? And I rotated my way through 400 degrees. So there's a picture of it. Now what I've been doing so far is I've been going in this direction, and these have been positive angles. It is also possible, and I'm going to clear the screen here, to draw negative angles. So let's just pull up the grid, and I'm going to draw a negative angle. Now, the initial arm always starts here, okay? And the difference between a positive angle, which would have swung upwards, or counterclockwise, is if I swing clockwise here, these are considered to be negative angles. So let's say someone said, draw me negative 30 degrees. No problem. I just swing down through 30 degrees, and this is now called negative 30. Okay? And of course, we can keep going. This would be negative 90 if I went to there, and negative 180 if I went swinging all the way through to there. Oh, by the way, the arm where you finish off, I don't think I mentioned, is called the terminal arm. Okay, so the initial arm is your starting arm, and then the part where you finish is your terminal arm. So we got positive angles going up this way and negative angles going down this way. All right, the next important thing to talk about is something called coterminal angles. I can clear the screen here and give us a fresh grid. What do we mean by coterminal angles? Well, I'll show you. Remember, we had 40 degrees, and we also noticed earlier that, hey, isn't that the same terminal arm if I swung through 360 plus 40 more? In other words, isn't 400 degrees end up in the same place? And you would be correct. So these are what we call coterminal. Okay, it just means they have the same terminal arm. So these are coterminal angles. Okay. Now there are going to be a billion of these and then some, because there's no reason I couldn't do another loop-de-loop, throw another 360 loop at it, okay, and end up here. So in other words, if I added 360 to this, okay, so if I just tacked in another 360, then I'd have 760 degrees, which is coterminal to the 40 and the 400, and so on. So I could just keep going. In fact, I could write it this way. I could go 40 degrees plus any multiple of 360. If I do that, I'm going to have coterminal angles. Now, I could also rotate in a negative direction. Like, what if I went in this direction and went, okay, there's negative 90, negative 180, negative 270, and then what do I need? I guess I need 50 degrees more to get to here. So that would be negative 320. That would be coterminal, right? And then I could do another negative loop-de-loop. So if I threw another negative 360 at it, that would also be coterminal. So what's that? Negative 680. So these are all coterminal angles. And of course, this little expression will actually generate them all, as long as n here is some kind of an integer. Then that'll generate all of your coterminal angles. So let's see how we're doing here. I think we have time to do just a couple of quick examples. And let's clear the screen. Suppose somebody comes along now and says, I have this angle of 1760 degrees. I would like the smallest positive coterminal angle to that. Okay? So somebody comes along and says that's what we want. Well, what you could do is take your 1760 and let's take away a rotation. Let's kind of back it up a rotation by taking away the 360. And depending where I end up, I could take away another 360 and, you know, kind of look at my answer, and I would just keep going like this until I get something that is between 0 and 360. Now, that's where you would want to end, because then you know if I do another subtraction of 360, then it's not going to be a positive coterminal angle. So the last positive one would be between 0 and 360. Now this method works, and if you keep going, I did this ahead of time, and I ended up with 320. And that is the answer. But this approach can be a little tedious. I mean, what if you started with something like, I don't know, 52,000 degrees? I mean, you can't just keep subtracting 360s. But what you can do is to say, hey, you know what? These are all multiples of 360, and I don't know how many of them. That's what I got to figure out. But I want to subtract a bunch of these 360s. So kind of what you want to do is say I want to take 1760 degrees and take away a certain amount of these 360s, these sort of backwards loops. And so the real question is, how do I determine how many of these 360s? And there's a pretty easy way to do that. What you do is you go, well, let's just take 1760 and divide that by 360. See how many 360s go in there. And you would get 4.8 repeating. Now what you want to focus on is this number and say that means there are 4 complete groups of 360. And then I have a little bit extra here. But why don't we take our 1760 then and take out 4 complete groups of 360. And if I do that, gee, I wonder what I get left over from there. Well, wouldn't you know it, you get 320, which is the answer. So this is a much more economical way to find these small positive coterminal angles. And I think I'm going to stop there and come back with another example of that and maybe some more stuff. So that's where we're going to stop for now.